after the equivalence point, we actually don't have to deal with an equilibrium at all. What we can say is the pH is going to be dominated by the excess hydroxide. So we started off with acetic acid. That's all now been used up since we're beyond the equivalence point. That's been neutralized by the hydroxide to give acetate and water. Since we're beyond the equivalence point, we actually have an excess of hydroxide. So we're going to say that's going to dominate the pH. So what we need to do is calculate what that excess concentration is. And you can do that by saying that if we know the number of moles of hydroxide, subtract that by the number of moles of acetic acid that we started with, which is a 1-to-1 ratio, so every mole of hydroxide is going to react with 1 mole of acetic acid. So subtract those, divide by the total volume. So the number of moles of hydroxide that we've added 30 mils, so 5 mils beyond the equivalence point, and it was 0.2 molar. And we're going to subtract the initial moles of acetic acid, which was 50 milliliters and 0.1 molar. Okay, that'll give you the number of moles of hydroxide that is still in the solution. The total volume was 30 plus 50, so we've got 80 milliliters. And that gives us a concentration of 1.25 times 10 to the minus 2 molar. To get the pH again, we can do is take the negative log to get the pOH. It's going to be somewhere close to 2. It ends up being 1.9. 14 minus that gives us the pH, which is 12.1.